In this project, we have analyzed and refactored the design implementation of the given bowling alley simulation project. We shall briefly discuss all the modifications and metric evaluations of the current version. Before that, let's look at the working of the project and responsibilities of each class. The drive class is the main class of the project. It initializes the game, sets parameters like number of lanes and maximum patrons per party. It also initializes all the necessary objects. The control desk window is handled by the control desk class. It assigns the lanes, creates parties, and maintains the wait queue. Each lane is handled by the lane class. This class is responsible to start a new thread for each lane and assigning party to that lane. It also updates the scores and acts like an observable to the subscribers. The pinsetter class constructs a pinsetter simulation and notifies the events to its subscriber classes. All the information of the bowlers will be stored and handled by the bowler class and bowler file class. The endgame prompt class pops after the end of the game to prompt if the player wants to play another one. The endgame report class allows user to take the game report at the end. Score report class creates the final score of each person in the party and sends their respective reports by email. Here we can see that there is no behavioral change from the earlier version.
So let's have a look at the previous and current designs created using UML. One of the initial and major changes made in this design is assigning classes to separate packages. So the reason being that the initial code base follows an MVC architecture, but everything was in a single package in the original design. So so why it follows an MVC architecture? For it so every view is linked to a separate model class. So here lane is a model class linked to lane status view. Control desk view is a view class linked to control desk and so on. So to organize this in a better way, we have split them into two packages. One is the model package, and the other is the view control package. So here in the model package, we have all the model classes, and in the view control package, we have all the view based classes. You might have also noticed that we got rid of some of the classes in the updated design, which mostly involve the event classes and observer interfaces. We look into that further in the next upcoming sections. Apart from that, we have also updated the methods. So let's look at one of the sequence diagrams for lane for the run method in the lane class. In the original design, it also involved two classes, endgame prompt and endgame report, which are involved in calculating the endgame logic. So after the user has exited the game, it calculates the final score. The problem is these two classes are assigned to the view control package. So in order to reduce the intermodule coupling, uh, we have transferred this logic to lane status view class. So this is the updated lane run method, which is void of these two classes. And for lane status view, we have transferred the logic to this particular sequence diagram. Speaking of the original design, there are certain advantages to it, like it follows an MVC pattern and coupling among most of the classes is kept to a minimum. However, we identified many code smells and anti-patterns present in this project. One of the code smell being the shotgun strategy. So it is when a single change involves multiple classes. So for example, here every observer lane is an observable class and it involves creating a lane observer interface and a lane event class. So lane status view listens to the events from lane class. So it has to implement the lane observer interface. So tomorrow under this current strategy, if a new model view pair is to be created, then that would involve creating another interface event pair. So also classes like lane status view subscribes to multiple observables. So here lane status view subscribes to lane and pin setter events. So this would also mean that a separate method is to be created for each observer interface implemented. So the lane status observer has to implement the receive lane event for the lane observer and the receive pin setter event for the pin setter observer. So this increases the number of methods as well. Therefore, in our updated implementation, all the observables extend the observable class and all the observers implement the observer interface. So the lane status view implements the observer interface and it has to implement one method, which is the update method. So we just have a single method for multiple. So even if we have multiple observables, there is just a single method to be implemented. And to check from which observable it is receiving an event from, it checks the instance of that particular observable. So in this case, it checks the instance, whether the instance is a lane or the instance is a bin setter, and accordingly, the logic is being executed depending upon the type of the observable.
Coming to metrics, we have analyzed the following metrics: CBO for coupling, lack of cohesion of methods, line of code, weighted method count, response for a class, depth of inheritance, access to foreign data, and number of methods. This table contains the metrics for the classes which had major changes. The old values in the table are just after dividing the classes into packages, and the new values are the final refactored output. As we can see, coupling has decreased for many classes as we have removed the event classes like control desk event, pin setter event, lane event for using the inbuilt Java observer and observable pattern. As we have extended the observer class in Java, the depth of inheritance also increased for these classes, as we can see here for lane and pin setter. Okay. Regarding lack of cohesion of methods, it has increased for pin setter as the pin setter event class is deleted and the corresponding methods of it have been moved into the pin setter. And the lack of cohesion has decreased for lane status view because instead of two receive functions in lane status view, receive lane event and receive pin setter event, we have merged it into one update function. Hence, lack of cohesion of method decreased. Okay. The report contains the details of the other metrics. Metrics have guided us to see where to start refactoring. For example, on looking at the coupling metric, we could see the lane and lane status view had very high coupling, hence we could start over there. And also looking at the access to foreign data, we could see we can find out which are the God classes. For example, control desk view has access to most of the other classes and the lane status view. Okay, and here are the individual contributions to the project. Arvind, Varun, Sarthak and Yochan. Thank you so much.